So what happens when you get these 2 atoms or 3 atoms together to make a compound? Well, the compounds are held together, no, the atoms in the compound are held together by chemical bonds. And these have to do with attractions between charged particles. And we can break chemical bonds into 2 different categories, ionic bonds and covalent bonds, and we'll look at those individually. So ionic bonds occur between metals and nonmetals. We looked at the periodic table in chapter 2 and learned how to decide from looking at the periodic table which is a metal, which is a nonmetal. So ionic bonds between metals and nonmetals, and these bonds involve a transfer of electrons. So that's not right. A transfer of electrons from one atom to the other. What happens is the metal will transfer 1 or more of its electrons to the nonmetal. What do you get when an atom loses electrons? You get an ion, and when it's lost electrons, what kind of a charge does it have? A positive charge, so we get a cation. So the metal atom transfers electrons to the nonmetal and becomes a cation. The nonmetal atom receives those electrons and becomes a negatively charged anion. The ionic bond then is the electrostatic attraction between the now negative anion and the positive cation. They're like magnets and they're attracted to each other. So we get an ionic compound, and the solid phase of an ionic compound is composed of a lattice, a regular repeating 3-dimensional structure. Have you ever played with magnetics? It's a magnet toy for children. There's little sticks and then there's little metal balls. And it's magnetic and they stick together and you can build all kinds of cool stuff. Ionic compounds are a lot like that, except instead of magnetic attraction, it's electrostatic attraction. But the little ball can be attracted to the sticks on multiple sides. I should get a picture of that. I have plenty of them in my garage. So that's what ionic bonds are. And here we have an illustration, a little small, but here's sodium. That's a metal. It's a very soft metal. You can cut it with a table knife. And chlorine, which is a gas at room temperature. And what happens is we get a neutral sodium atom, and it will donate 1 electron to the chlorine atom. So we then have a sodium ion and a chloride ion, and then those are attracted to each other. And they will arrange in a regular, repeating, ordered manner to form sodium chloride, table salt. Sodium metal is a very reactive metal. You throw it in water, it explodes. Chlorine gas, toxic. Sodium chloride, good to sprinkle on your steak, right? You need a certain amount of it to be alive. And it has a crystalline form. If you go home and look at the salt in your salt shaker, it's little tiny cubes. The people at Morton's Salt did not go to special pains to make that into little tiny cubes. That is the way the salt naturally forms. It's kind of hard to get it to form any other way. And that's because of how the ions are arranged in the lattice. The other type of chemical bonds are covalent bonds. We have a lot of prefixes in science. We make use of them. Co, what does co imply? Sharing, right? Co-sleeping is a trend among young children. Young children love co-sleeping. That means they come and sleep in your bed with you. They share your bed. They share your sleep. Actually, what they do is they disrupt your sleep. But co involves sharing. So covalent bonds occur in between 2 or more nonmetals. Metals don't do covalent bonds. They just don't. And this involves a sharing of electrons. So covalent bonds is sharing. The ionic bonds, it was a transfer. So the 2 nonmetals get close to each other, and neither atom is willing to give up an electron to the other one to form an ion. And so what they do is they share some of their electrons. And we'll talk more about covalent bonds later. But for now, what you need to understand is nonmetals form covalent bonds with other nonmetals, and involves sharing electrons. So the covalently bonded atoms then compose a molecule. Ionic compounds don't really form molecules. They form an ionic compound with a lattice, but it's not actually a molecule.